Alright, welcome to 6.8 part 2 video. We just got another example to look at. At the beginning of an experiment, a scientist has 460 grams of radioactive material. After 50 minutes, the sample decayed to 80 grams. Find the exponential function p of t of the material. What is the half-life of the material in minutes? And how much material is left in 115 minutes? Alright, so we need our formula. Since they asked us for p of t, so instead of saying a of t, we'll go p of t. And so instead of a sub 0, we'll put in p sub 0. And p sub 0 is always your beginning value, so that's the 460 grams of radioactive material. So what we have here is they give us time. After 50 minutes, we have 80 grams. So t is 50, and therefore p of t, or p of 50, has to equal 80. So 80 is going to go to the left side. We'll put 460, we'll put 50 in for t, and we can solve for k. There's my substitutions. So in order to solve this, we got to isolate our base e, so we'll divide over the 460. Again, if you want to start to reduce or just leave it alone, that's up to you. And here, because it's base e, we're going to convert it to a natural log. So that means the natural log of 80 over 460 is now equal to the exponent k times 50. We'll divide over the 50 and go to the calculator and enter everything. Now, notice in my calculator entry, I hit the store button. Now, the store button is right above the on button. And I stored it for k because it's a long decimal. And in these word problems, the more decimal places that you write down, the more accurate your answer is going to be. So here, let's see, because we got 99, we'll just stop here. We'll call that 3 of 4, and we'll put that in for our k value. That should be still giving us a pretty good answer. But if you get some kind of decimal that really doesn't approach or rounds well, like it sticks at a 5 or a 6 or a 4, we'll just use k in the calculator, and that's what I'm going to do to answer this question here so you can see it done. So here's my function, got that done. Now, what is the half-life of the material in minutes? Well, what we're going to do is take our formula here, take half of our starting value, 460, that'll be 230, put that in for p of t. Divide, well, we got to do the exact same work as we did up here. Divide over the 460, that makes it a half, or if you wish, 0.5. Then we're going to have to convert this to a natural log. Natural log of 1/2, or 0.5, equals, come back here, negative 0.0344984 times t. Divide this decimal over to the natural log of 1/2, and that will give us our time. And so as you can see in my calculator entry, I just did natural log of 0.5. And because I stored my value, this long decimal, in for k, I just divided by alpha k, which saved me a bunch of pushing of buttons so I don't accidentally type in the wrong number. And that's going to give me approximately 19.8 minutes. How much material is left in 115 minutes? Okay, we'll just go right back to our function that we created in the first part. And we'll put 115 in for t, and we'll go to the calculator. So there's my substitution of 115. There's my calculator entry. Again, 460. E to the, again, instead of using that, typing that decimal, I'm just going to use my stored value k times 115. And we get the answer of 8.2323. And we'll call that in grams. Or we'll round it to wherever the directions tell us to round it. And that concludes this section